The expression 1 plus 1 over x in the solvent is equivalent to the rational expression x plus 1 over x. A rational expression is the quotient of two polynomials. You will find that, at different times, it is helpful to think of rational expressions as ratios, as fractions, or as quotients. A rational expression is in simplest form if its numerator and denominator are polynomials that have no common divisors other than 1. You simplify a rational expression by dividing out the common factors in the numerator and the denominator. Factoring the numerator and denominator will help you find the common divisors. Note some examples. First, on the left, in simplest form, x plus 1 over x minus 1. No common divisors. And x squared plus 3x plus 2 over x plus 3. Note, even after factoring the numerator, we would have no common divisors. X plus 3, the denominator, is not a factor of the numerator. And on the right, not in simplest form. Our first example, x over x squared. Note we have a common divisor of x. Next, 3 times the binomial x minus 3 over the binomial x minus 3. Common divisor, x minus 3. Finally, x squared minus x minus 6 over x squared plus x minus 2. Notice that after factoring both the numerator and denominator, we would find a common factor or common divisor of x plus 2. A rational expression and any simplified form must have the same domain in order to be equivalent. So note, x squared minus x minus 6 over x squared plus x minus 2 equals x plus 3 times x plus 2 over x minus 1 times x plus 2, a common divisor of x plus 2, and x minus 3 over x minus 1, having reduced the fraction, canceling the common divisor x plus 2, but taking note that x cannot equal negative 2, that would lead to a zero denominator in our original expression, are equivalent. In the example above, you must exclude negative 2 from the domain of your simplified form x minus 3 over x minus 1, because negative 2 is not in the domain of the original expression x squared minus x minus 6 over x squared plus x minus 2. That would lead to a zero denominator. Note that this restriction is not evident from the simplified expression x minus 3 over x minus 1. X plus 3 is the simplest form of x plus 2 times x plus 3 over x plus 2, but x plus 3 and x plus 2 times x plus 3 over x plus 2 are not equivalent. X plus 2 times x plus 3 over x plus 2 and x plus 3 need to have the same domain to be equivalent. The domain of x plus 3 is all real numbers, but the domain of x plus 2 times x plus 3 over x plus 2 excludes negative 2. That would lead to a zero denominator. Problem 1. Simplifying a rational expression. What is x squared plus 7x plus 10 over x squared minus 3x minus 10 in simplest form? State any restrictions on the variable. First, factor the numerator and denominator. In order to identify common divisors, we'll need the fully factored form of both of these quadratics. X squared plus 7x plus 10 factors nicely as x plus 2 times x plus 5, and the denominator, x squared minus 3x minus 10, factors nicely as x plus 2 times x minus 5. Next, we'll divide out the common factors, x plus 2, and simplify. Our expression becomes x plus 5 over x minus 5. The simplified form is x plus 5 over x minus 5, for x does not equal 5, and x does not equal negative 2. The restriction x does not equal negative 2 is not evident from the simplified form, but is needed to prevent the denominator of the original expression from being 0. Your turn, part A. What is the rational expression 24x cubed y squared over negative 6x squared y cubed in simplest form? State any restrictions on the variables. Part B, same instructions, but the expression is now x squared plus 2x minus 8 over x squared minus 5x plus 6. And part C, once again the same instructions, but the expression becomes 12 minus 4x over x squared minus 9.